Our game teams run on Windows using Visual Studio as their IDE, so we support that integration. Comes with a graphs compiler, a linker, our own debugger, a distributed build system. People really like that. We have performance hooks into the chip so you can see what's going on in real time. The usual supporting binary utilities. And we'll throw in a CPU compiler for free. And we brag about that. You guys know all this stuff. We do promise to the game teams that we will keep up to date with new releases from LLVM. And also any patch releases and features that we add ourselves. And comes with the whole usual set of intrinsics that comes with the Clang. We're sort of compatible with everybody. This is one thing that we make a big point of to the game teams, this last point. If you have any undefined behavior in your C code, C++ code, Clang will bite you. So please be very careful of that. You know, you've all seen the traffic on the lists about that. We have to make a special point of it with our game teams. We've mostly cleaned that up now. We have our own in-house linker. Last time we checked, it was about as fast as gold. The extra fancy thing about the linker is it has this extra dead stripping features. It can do function dead stripping and variable dead stripping and deduplication without having to emit a separate function per section in the ELF. Does not yet support bitcode, but we have evaluation. There's one of the lightning talks this afternoon. Gal will talk about that, but it's definitely on our list. Debugger integrated with Visual Studio as well. Does core dumps, threads, all that good stuff. All right. Why did we pick Clang? I'll have to do a little bit of history about this. We traditionally provided GNU tools for the PlayStation toolchains. There was this company called SN Systems in Bristol that got into the tools business. They had a lot of in-house stuff. People really liked their toolchain. They got their compiler from a company called Apogee down in San Jose, here in the Bay Area, using an EDG front end. I understand that Apogee actually was one of the first, if not the very first, EDG customer. A little bit of compiler trivia there for you. And they built their own back end, specifically intending to target the risk markets. So the toolchain was very successful to the point where we actually bought the company. This does mean that we have two PS3 toolchains, the GNU one and the SN toolchain, but you know, something we have to live with. Now, PS4 is in the initial architecture stages. The decision to go with x86-64 comes fairly early on. The problem is that x86, not exactly your classic RISC architecture. So it's not going to be feasible to retarget SNC. So we need to find another compiler. We could just go back to GCC, but Worldwide Studios had been doing work with Clang and LLVM since about 2008 or so. And it was the new kid on the block, so it was definitely worth taking a look. So if you look at all the possibilities, just go back to GCC. There's this LLVM GCC thing that was in tree at the time. We could take the EDG front end from our existing toolchain, glue that to LLVM, or just use Clang. We did do a technical evaluation, looking at compiler performance, compile time, runtime performance, and standards conformance. We had, I think, 2 different conformance suites. And there was not a clear winner out of all of our choices. Some better at conformance, somebody's better at compile time, somebody's better at runtime, so that was not conclusive. And much as we would have liked to stick with EDG to guarantee compatibility with our previous SN toolchains, there were some reasons not to do that. We had done the glue in-house, but we talked to EDG and they did not want to pick it up. They did not want to adopt it. which meant that we would have this hunk of code which we would have to upgrade every time we took a new EDG drop or every time we took a new LLVM drop. And that permanent ongoing maintenance cost was not very exciting. ARM, it turns out, had done something similar. They had a talk here 3 years ago, pasting EDG onto LLVM. And the assessment is, their experience was pretty similar. Some things worked really well, some things didn't work so well. And again, EDG not interested. I'm told that debug info in particular was a problem getting it from the EDG front end into LLVM. I wasn't there. I don't know what the problem was. So yeah, so these non-technical considerations really drove the decision in the end. So we had these minuses against EDG, but we looked at Clang again and observed that even though in the moment, Clang was about on a par with GCC or EDG, it was vastly improved over where it had been 6 months previously. And that was a trajectory that we really liked. That the community was obviously committed to improving both the conformance and the performance of the compiler. And obviously, Clang and LLVM come as a match set, so we didn't have this glue maintenance kind of issue if we chose Clang. And in the end, we are very happy with Clang. All right, what might be a little different about our situation? So just as the compiler is only one piece of the toolchain that we provide, the toolchain is only one piece of the entire package that we provide to our licensees. We have a whole SDK with a bunch of samples and helpful hints for even the small game teams to get started producing games. We have a developer services organization. If you're familiar with the usual sort of 3-level enterprise support system, they're basically levels 1 and 2 put together. I love talking to these guys. They always have insights about what's going on out in the studios. We provide a bunch of manuals. The ones relevant to the compiler, there's a compiler reference, which basically means command line option descriptions. There's a transition guide, how to use Clang if you're starting from SNC or GCC or Microsoft, a short ABI overview, and an intrinsics reference manual, which is basically a man page per intrinsic function for all of the, 700 or so intrinsic functions that we provide for x86. Game teams are not interested in upgrading their tools very frequently, so we do a lot of testing beyond what happens upstream. We have, as I said, 2 different conformance test suites. We have our own internal regression tests, and of course, functional tests for anything that we've done. Licensees, I have to remember not to call them customers. Customers are the people that buy the boxes. The people that use the toolchain, they're licensees. So there's a lot of these guys. Some are owned by us under the auspices of the Worldwide Studios Organization. These are called first-party studios. Everybody else is third-party. Nobody's ever explained to me whatever happened to second-party. I don't know what the exact breakdown is, but we have a total of around 1,000 licensees at this point, and we expect that to grow because, the box hasn't even launched yet. Geez. And what they build, I like this particular description: massive, real-time, graphics-intensive 3D simulations, and you call it a game. You have never seen so many vectors in your life. Maybe you do 3D modeling yourself. It's like, okay, in that case, you understand what's going on. There's a lot of stuff going on besides the C++ code. There's all the GPU kernels, and there's these things called assets. This was a new term to me. I didn't know about games and graphics stuff. So it turns out that the data build really dominates the build time. If you're going to build the entire game from scratch, you're pre-computing all kinds of graphics, textures, shading, lighting, all that stuff. You pre-compute as much of that so that you have it. You just load it and go, if at all possible. I'm told that typically game development effort, around 10% of the effort to producing a game is the C++ code. Maybe 20, 30% is testing, and the rest of it is building these assets. So, yeah, the C++ code is a small piece of the whole effort, but it still has to go fast because you're trying to produce 60 frames per second. Now, 16 milliseconds means you can do more with it now than you could when I started out in the computer business, but still not a huge amount of time. You also have these huge data assets that need to be loaded into memory so the GPU and the screen can get at them. They consume a whole pile of memory, so this code has to be small. What this means is that if you build your game at 0 or 01, it's not that it will just run slowly or not work too well. It won't work at all because you can't keep up with the hardware deadlines. One trick that some studios have used to get around this is a thing called Unity builds. I've started calling this sort of the source level LTO, because you basically pound include all of your C++ code into one monster compilation unit. And so you get, the compiler can see everything. We're hoping to get LTO running and be able to parallelize more of what's going on. Something we'll have to look at. So, what do these things look like that the games produce? This is a short, just 1 minute clip. It's PlayStation, we gotta have a video. When there's dialogue, basically that's a pre-programmed cutscene. The rest of it is capture of live gameplay. No, that's not supposed to happen. There.
That's 2 out of 3. When it comes to conduits, it's my call. Not yours, not ours, mine. I love meeting new people.
All of that debris and stuff flying around, all the physics of that handled by the CPU, not the GPU. So it's like there's a lot of stuff going on the CPU has to keep track of. For posting on the website, I have links to some longer videos of the same game. All right, what have we done with Clang and LLVM? Well, first off, who's been doing it? Not to get too deeply into Sony internal corporate structure, but the technology platform organization is responsible for producing the box. The Toolchain in particular, overall responsibility with SN in Bristol. Then there's my team, US R&D. We are part of the Clang and LLVM development, 3.5 people currently, and 1 empty seat in case anybody's interested. There's also a small pseudopod of SN systems down near San Jose doing PS3 and Vita work, and the runtime stuff is all happening in Tokyo, along with the rest of the system stuff. Separately from that, there's the Worldwide Studios organization. They own all the studios. There's also a tools and technology group. He had guys everywhere doing all kinds of stuff, including a bunch of Clang and LLVM work. If you know Alex Rosenberg, that's his team. So things we've done to the driver, obviously it's a cross compiler, so we have to change the target. We went with C++ 11 by default, and supporting only one C++ dialect. We didn't want to be stuck with 03 baggage. We turn off exceptions in RTTI by default because it takes up a lot of space and basically no game teams use these. PIC is a platform requirement. Stack Protector Strong we adopted from GCC, well, re-implemented based on what GCC had done. Hopefully John Criswell is not in the room, and I can say that this was at the request of our security team. Although, in fact, so far it has actually caught 2 real bugs, one in our middleware and one at a studio. So we're real happy about that. And we have a frame pointer because getting stack traces without a frame pointer is a real pain, especially when it's all optimized. And the driver looks where we put our headers and libraries. In Clang, we've done some stuff with pragmas, especially pragma comment lib. I think this is all coordinated with upstream at this point. Did some work with Windows hosting, everybody's favorite /hosting, separators, / quoting. We have to support non-ASCII characters in path and file names. Domo arigatou gozaimasu. We will take the intrinsic function manual. This hasn't happened yet, but it's in plan. Break that up, convert it to Doxygen, put it into the actual headers. This benefits the community because you guys get all of the descriptions that we've written. We benefit because then we can post-process the Doxygen and get Visual Studio tooltips out of it. At one point I had implemented a hack to reduce, we got a lot of debug info size issues. One thing we've done is anytime you have a class description and there's methods in it that you don't use in a particular compilation unit, we don't put that into the dwarf. As a dwarf committee member, this makes me cringe. But it saved something like reduced debug info size by at least 60%. So it was definitely worthwhile. I'm hoping that we can throw that away and replace it with type units now that type units are in. But being as it is contrary to the spirit of the dwarf spec, it's not something that we can put upstream. On the LLVM side, the exact model that we picked actually went through a couple of iterations over time, but there were always some instruction subsets that in a processor that we picked that weren't defined upstream. We implemented all of that stuff and then sat and watched other people do the same instruction subsets upstream, which made us all very sad. We did manage to salvage the TBM subset. We put that upstream earlier this year. The irony, of course, being that Jaguar doesn't support TBM. We've done some other back-end tweaks. We had to do some relocation changes so that the relocations have the correct information that the linker can use to do the spiffy dead stripping. And I've more debug stuff. I've fussed with fast ICEL to help the line numbers line up with the instructions a little better. GDB doesn't seem to have as much of an issue as our debugger does. So it's like not real urgent to get that upstream, but it's something we've had to do. Okay, working with the community. Sorry. This first slide could be called not working with the LLVM community. Every company has its secrets. PS4 was no exception. It was more secret than you think because obviously projects have code names. Well, in this case, even the code name of the project was a secret. This really happened. I called up IT one time, and the guy on the other phone said, are you working on the project whose name I cannot say out loud? It's like, yes. Really. So this meant that we were basically working not completely in isolation because the WWS guys were doing some stuff and they could sort of back channel some information for us. But mostly we're reading the lists, watching things, but we cannot contribute back. We can't get feedback from the community. We can't get design help. We can't get patchers reread. We're doing all of this stuff on our own. We made a case to management that there is clear value to more open communication and that this is something we really want to do. And the list of stuff is up there. I'm not going to go through it. And management said, okay, with the caveat that we still can't say or do anything that has any indication of what our actual target is. So this means we can do in general, any kind of Clang stuff we want, and any kind of target-independent optimization work, we can work with upstream on that stuff, just nothing target-specific. Although I wrote some number of bugs in emails saying things like, on my Ubuntu x86-64 workstation, I see this happening, and never mind that I actually tripped over it on a dev kit. You know, it was all true. I can reproduce it here, so it's okay to talk to upstream about it. After the big reveal, of course, that's not an issue anymore. As far as I can think of, that there's nothing left that is still secret that matters as far as the compiler is concerned. We've evolved our workflow. It always has put this upstream component to it. For the trickier stuff, we're definitely trying to do that first. But you know, we have a lot of backlog, multiple thousands of lines of backlog to work through, and we'll eventually get that upstream. Because the merges are an endless nightmare. I'm deeply scarred by the merges. We used to merge only on an upstream release. I did the 3.0 merge. I tell people it took me 3 months. I kind of wonder if that's really true, because it seems to be costing more these days. After that experience, I took to my management, and we agreed that the thing to do was to try to live closer to trunk. We have an active project going on. We're trying to catch up. We're going to get there. If you're living on trunk, you can do automation to pull changes from upstream. You can find merge issues right away, deal with them, in ones and twos instead of having to do 6 months of work all at once. And anytime you put a patch upstream first, it comes back to your trunk automatically. So we did decide to keep our releases to the licensees based on upstream releases. We did a midstream release. I was doing like 2-month chunks for a while, and we put out an SDK, and it was not one of our more successful SDKs. We got a lot of feedback about that. The extra testing and qualification that happens for an actual upstream release is enough of a difference that we're gonna stick with that. It means that our branch system is going to be a lot more complicated, but I think the branch pain will be a lot less than the merge pain has been. All right, I'll tell you a little bit about what the studios are telling us. I have quotes from 3 different studios. Not these guys, but I have heard that some of the studios have been so impressed with the Clang toolchain, Clang-based toolchain, that they are moving to use PS4 as their primary game development platform, their primary target, just because of the toolchain, and that's an incredible endorsement of the usefulness and success of Clang. We're really happy about that. These guys, Gearbox, compared to GCC, order of magnitude reduction in iteration time. Very impressive. Everybody likes the warning and error messages. Even though using Visual Studio, you get the messages, you don't get the sparkly colorized highlighting, but everybody loves the extra diagnostics. Link time, hugely improved in this case compared to Microsoft Linker. I love this last quote: typo correction as pretentious as Google search. So they love us, yay. Fortunately, none of these guys had just come off of a debugging session because, as I said, games are always built with optimization. So people say the studios have low expectations of the quality of the debugging experience, and we fully meet those low expectations. There's talk about improving the quality of debug information in optimized code. At HP, I had a project to do exactly that, and it turned into just one long succession of individual bug fixes. 8 or 10 different places. I tweaked this place, I tweaked that place, I tweaked another place, in order to improve the overall debugging experience. There's no silver bullet, in my opinion. You just have to find all the places where you're losing track and just keep going. What the studios have asked for is a way to say, let's not optimize this function so that, build just this function at O0 so that the debug info is reasonable quality. Microsoft supports this, GCC supports this, SNC supports this. I'm hard-pressed to come up with a compiler that doesn't support this, except for Clang. We get feature requests from the licensees all the time. This is the most popular request by an order of magnitude. They all want it. So what we've done is we managed to define the opt-none attribute on a function, and that's upstream. It's been pulling teeth to get any further than that. Because everybody says, oh, you can't touch the pass manager, oh my God. So, okay, we'll try not to touch the pass manager. Well, we'll do something else. Well, that doesn't work either. And it's like, everybody has a different opinion of how it should work. If you have an opinion, please talk to us. Please help us get us in. Because this is something that we're going to have to do. We would rather do it, pick some solution that the community is happy with rather than just, do it ourselves and hope for the best. A few other things on the wish list. Developer services people would like to have a way to say, oh, let's figure out which optimization, you have your race car game and it works fine except all of the cars are upside down. This really happened. And so what optimization is it that's causing this problem? Well, with some compilers have a way to say, do the first 35 passes and stop, and then you can bisect which optimization is causing the problem that way, pretty much. Clang LLVM don't really have that. Opt sort of does. It says go stop here, but it's opt, not Clang, and you have to know how the pipeline is constructed in order to figure out where to make it stop. So we'd like, something that works better than that. Bug point with meta renamer, just a way to obfuscate the bug reports that we provide. And, they like other little things. Static analyzer is right there. We're keeping an eye on the profiler changes because people both want code coverage and PGO. Sanitizers, everybody's excited about. We need to get our act together and figure out how to do the runtime support inside the box to make that work. So, Clang has been a real asset to our toolchain. It's, the studios love us. And thank you very much for your help making our platform a success. Thank you.
Okay, Paul, good job on making up the time. So we have a few minutes for Q&A. Is there a question or two that you guys have?
So this might be a silly question, but couldn't you just compile the one function you want to not be optimized in a separate source file with O0 and take it out of the Unity build that you mentioned and compile everything else with O2? I feel like I must be missing something.
That's a common approach to it, yeah. Think about your project. How easy is it to pull out just the pieces you want to debug and compile it separately? It's really inconvenient. It's a big pain. It's not convenient for your iteration time to be constantly mucking with the source and fiddling with the project settings and stuff. People do that, but they would rather not have to.
Okay. Any other questions?
Thank you. First off, thank you for all your work with Clang. It's great to have you being more involved with the broader community and things like that. It's fantastic. You made a very interesting comment about your testing infrastructure, that you find that the release testing for the LLVM releases provides additional value over the standard rolling testing, so you're still basing your branches off of that.
Right.
Can you elaborate on that a little bit, and specifically if that perhaps indicates that there's something that we should be doing differently in our rolling testing
Right.
to provide that same value, to give you more flexibility, and thus the rest of the community that same flexibility as well?
Well, there's a couple things. One is that, yes, there's additional testing. I think another aspect of it is that when a release is coming up, people make an effort to make sure that anything big that they're putting in is finished. Okay, so one of the problems that we had with our midstream release is that the new SROA was in place, but it didn't handle all the corner cases, and we pump enough code through it that we trip over them. And I think that those two aspects of things really make a difference. We're just pumping so much code through it. I hope that answers the question.
Okay, let's thank Paul one more time.
All right.